So we are going to look at two properties or two rules of exponents today, and then we've got three more we're going to look at on Wednesday. An exponent is the number of times a base is multiplied by itself, and that base can be a number. So like Hunter said, 2 squared, so 2 squared, 2 would be the base. It can be a variable like x, or it can be both. So like this one right here is 3y, that's our base. We are going to, instead of me just telling you the rules, we're going to kind of discover them and see if you guys can see where they are coming from. So we've got these examples here, and what we are going to do with them is called expand them. So that's what you guys were saying out loud just now. So A here, we have x to the third times x to the fourth. So you guys just told me that x to the third means x times x times x. You told me that x to the fourth means x times x times x times x. So I've got 3 x's, and I've got another 4 x's. So I'm expanding that out and making it have no exponents. If I wanted to squish that back together, what would my exponent be? 7. I've got 1, 2, 3, 4, 5, 6, 7 x's there. So I've got x to the power of 7. Awesome. Hey, this next one is super similar. We've just got that one extra x on the end. So I've got x to the fourth again. 1, 2, 3, 4. Let me write my x is kind of small. And I've got 3 of them. 1, 2, 3. And I've got one extra one at the end. Putting that all together, how many x's do I have? 8. So I've got 4, 5, 6, 7, 8 now. So we've seen it with just x's. This last one we've got here, example C, is y's. It's a different letter, but then it also has a number involved. So 3y to the 5th power means 3. And then we've got 5 y's. So we've got 1, 2, 3, 4, 5. I would like to point out that the 5th power is just on the y. It's not on the 3. Then I've got 2y to the 4th. So I'm going to put my 2 down. And I'm going to put 4 more y's. 1, 2, 3, 4. Okay. With this one, you got to treat the normal numbers, the 3 and the 2, they are still normal numbers. So if I've got a 3 over here that's going to be multiplied by a 2 over here, 3 times 2 is just 6. There's no exponents on it. There's no wacky stuff. We just multiply those numbers like normal. Then for our y's, we can just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Any questions right now about expanding and then condensing those? Okay, so turns out expanding those is not a practical way to do these problems because it takes forever, and we shouldn't, as Algebra 1 students, be relying on counting. Like, we're past that. That's like 2nd grade, we're past that. So we shouldn't just be counting things up in the long run. Take a second by yourself without talking to look and see if you can find the pattern of how we got to x to the 7th, x to the 8th, y to the 9th. So don't say anything yet. I want everyone to look at it on their own. Okay, now turn to the person that's closest to you. I'm not going to like assign you a partner, just turn around. What can you do to get from here to there without expanding all of this? Speak to each other. Emiliana, Hunter, speak to each other. Gabby, you can either talk to Lamar, or you can turn around and talk to Cameron and Peyton. How can we get from 3 and 4 to 7? 4 and 3, and this x by itself to 8. Okay, what can you guys do with those exponents? Add them. So to multiply terms that have the same base, we can simply add the exponents. So I want to go back and show you that that worked. 3 plus 4 is 7. This one's kind of tricky. 4 plus 3 plus what exponent is there? A 1. So just like with polynomials we put in our imaginary ones, we're going to want to put in imaginary ones today. So 4 plus 3 plus 1 is 8. And then 5 plus 4 is 9. Awesome. So that is one of your exponent rules that you guys will be using today. All right, any questions about those? Okay, let's move on down to these next guys then. So this next rule that we are looking at, we've got stuff in parentheses with exponents, and then there's more exponents outside. So we could expand this all the way. We'll do that on the first one. We're not going to do it on the rest of them. So x to the third in of itself means x times x times x. So this means we've got x times x times x. That's the first x to the third. And then we're squaring that. So we've got another one of x times x times x. How many x's do I have total there? 6. All right. Next one, instead of writing out the y squareds, I'm just going to leave it as y squared. So we've got 2y squared to the third power. So what that's going to look like if we expand it is 2y squared times 2y squared times 2y squared. Okay, I want to deal with those coefficients, those big 2's first. If I need to multiply all those together, what is 2 times 2 times 2? 8, not 6, 8. Then I'm going to use my product rule that we just came up with, the adding one, and I'm going to add 2 plus 2 is 4, plus 2 is 6. This final answer here is going to be 8y to the 6. Okay. And then this last one here is the first one we've seen where we have more than one variable. So you can have multiple variables be part of your base. So I've got a cubed times b, and that's to the third power, so I should have 3 of those. A cubed times b, a cubed times b. Okay. I can use my product rule to add up all the exponents on my a's, all the exponents on my b's. So a's should be 3 plus 3 plus 3. That's going to be 9 total. So I've got a to the 9th power. And then how many b's do I have? 3. So I've got an imaginary 1 plus 1 plus 1. You need to add those in, add them in. A to the 9th, b to the 3rd. All right, so I would like for you guys to take a second. See if you can see what operation, what pattern is happening here to raise a power to a power. How can we get from 3 and 2 to 6, 2 and 3 also to 6, 3 and 3 got us to 9, and then an imaginary 1 here, 1 and 3 got us to 3. What operation are we doing there? Multiplying. So to raise a power to a power, we are going to multiply the exponents. Okay, so those are the 2 rules that we need to know today. We need to know product rule. We add the exponents. So for multiplying them together, they're on the same level. We add the exponents. If it's a power to a power, I guess this way for you guys, power to a power, that's when we multiply the exponents. Did I say that wrong? If we're multiplying, we add. If we're doing a power to a power, we multiply. Okay, so go ahead and flip this over. We've got 6, I believe, examples on the back of actually using this, because we're not going to expand this out every time. Hunter, wake up for me, please. Watch these examples. Okay, so we're going to have to pay attention to which rule they're going to be using today. We've got product and power. So what I look for is if I've got an exponent outside of a parentheses, it's power. So this first one here, this is going to be a power rule. F to the 4th, g to the 5th, all to the 6th power. So what I'm going to do is I'm going to multiply, and I know they're tiny, that 4 times 6 together. I'm going to have f to the 24th power. And then this g to the 5th times g to the 6th power. I'm going to multiply 5 times 6 together. I'm going to have g to the 30th power. And that example right there is why we have these rules, because it would never be practical to write out 24 F's and 30 G's. Okay, this next one we've got, all I have is multiplication, so this is going to be my multiplication rule. Put your phone away if you have your phone out. Negative 3 times 4 is negative 12. My normal numbers, I treat like normal numbers. And then x to the 3rd and x to the 5th. I add those together because they're both x's as my base. So I get x to the 8th. And then I've got y to the 4th and this one extra y right there. So I can put my imaginary 1 on. 4 plus 1 is 5. So y to the 5th. So I am adding my exponents for the product rule. Okay. Any questions on either of those first 2? Okay. So we got a couple more, or I guess 4 more. This next one, treat your normal numbers like normal numbers. So 2 times 5 is going to be 10. And then I add my exponents. 11 plus 3 is 14. Okay. I've been saying treat your normal numbers like normal numbers. Treating your normal numbers that are to an exponent, we still treat them like a normal number, but exponents aren't as normal for us. So right here, when we've got 4m to the 5th, since that 4 is in parentheses with this, that means we need to do 4 to the 4th power, because there's an imaginary 1 right there technically, and then m times 5 to the 4. We multiply our exponents for power rule. 5 times 4 is 20, so this is m to the 20th. If we have a base that is just a number, we do want to find our answer to that. So 4 to the 4th means 4 times 4 times 4 times 4. You can do that in your head. You can type out all of those 4s in your calculator. Or in your calculator, we call it the caret button. Looks like a carrot coming out of the ground, maybe. No, that's not Y. That's a different caret word. I don't know. I'm not an English teacher. But you can put in 4 to the 4th power. It's going to look like that. 256. Or you can do 4 times 4, which is 16, times 4 is 64, times 4 is 256. Okay? So 4 to the 4th power is 256. This is going to be 256 m to the 20th. You guys saw when we did the example on the front, the one with the 2 out in front, we did 2 times 2 times 2. That would be 2 cubed. 2 cubed is 8. 2 to the 3rd power is 8. All right, we've got 2 last problems here. This next one, we have to use that same rule of we are squaring a normal number. So we've got -3 squared. Anytime we have a negative number and it's being taken to a power, we want to keep its parentheses around. Then I've got my x to the 1st power here. So I use my power rule and I multiply. 1 times 2 is going to be 2. And then I use my power rule again. 6 times 2 is 12. What is -3 squared? 9. Why is it positive 9? Yeah, so -3 squared means a negative times negative, so that's why it becomes positive 9. So I've got positive 9 x squared y to the 12th would be my final answer on that one. Hey, very last one for today. We are going to multiply the normal numbers like normal numbers. We're back to product rule. So 2 times 3 is 6, times 2 is 12. I'm going to add my exponents on my m's, as in margarine. Why is that the first word I thought of? 2 plus 7 is 9. And then on my n's, as in nectarine, 2 plus 3 is 5, plus another 5 is 10. Okay. Any questions right now? Okay, I'm going to have you guys glue this in just after 5.9. So we're not starting a new pocket. We're not starting a new section of our notebook because it's just these 2 extra days before spring break. It's not worth it. So glue these in after 5.9. And then you've got an assignment today. We're going to get done as much as we can. I think some of us might get done. If we don't get done, tomorrow's a block day or Wednesday's a block day. We'll have time to finish them. So we'll bring around assignments. Stop this video.